Welcome to 52. I'm talking about problem 15 from section 5.2 of the Hughes-Hallett text. In this problem, you've been asked to find the area between the x-axis and the curve y equal cosine t for t between the values of 0 and pi over 2. You don't have any techniques for doing this at this point other than using your graphing calculator, which is why I've got one out, and that's exactly what we're going to do. So here's the basic fact we have. You got to do it numerically at this point. You have no choice. So let's go over to our graphing calculator and let's take a look at this function. Let's put in a function that we're going to graph of the cosine of x, and let's try that again because I have a tendency to hit way too many parentheses. Alright, there's our cosine of x that we're going to graph, and let's set the window. We're interested in x values between 0 and pi over 2. So let's put in pi over 2 for our largest x value. And between 0 and pi over 2, the cosine is going to start out at 1 and run on down to 0. So we know it's not going to go negative, so we'll put in a y min of 0 and a y max of 1, and then let's graph it. And there you see the cosine of x running from 1 down to 0 as x runs from 0 to pi over 2. Now, in order to find the area under that curve, there's a nice feature on the calculator which you can get at from the calc button right up here. So I hit second calc, and option 7 gets me an integral, which in this case, since I'm dealing with a function that's above the x-axis, that integral is going to give me area, which is what I'm looking for. So I hit option 7, and it asks me for a lower limit. It's wanting to know what's the lowest x value where I want to start finding the area, and I want to start at x equals 0, so I put in 0. And then it wants an upper limit, and I want to go all the way up to pi over 2, so I put in pi over 2 as my upper limit, and I hit enter, and it shows me the area it's calculating, or the integral it's doing, and it comes up and tells me that that area is 1, which is exactly what we were looking for.